All right, let's look at the homework 4.3, problem number 9. So we have f of x equals x e to the negative x, and we want to find a bunch of these guys. All right, so let's find those first. Let's look at the relative min, relative max, and the inflection points, and so on. All right, so let's find those. All right, so first I'm going to look at the first derivative, f prime of x, which is equal to, we have the first guy, which is x, and the second guy is e to the negative x, right? So derivative of the first guy is 1, so we're going to use the product rule, and times the second guy, just copy the second guy, plus copy the first guy times derivative of the second guy, which is negative e to the x, but you have to multiply by the derivative of the power, which is negative 1. Right? So if you factor out common factor, so e to the negative x, so I'm going to pull that out, so maybe I'll pull it out here, e to the negative x. Then you multiply by, so you have a 1 from the first term, you have a negative x from the second term. Right? So that's the first derivative. So we set that equal to 0. Right? We know that the exponential function here is never 0. In fact, it's actually positive. So if you want to make it equal to 0, we have to make this guy equals 0, so x equals 1. So this tells you that x equals 1. Right? So we found a critical number. Right? Then what we can do is we can find out about increasing, decreasing behavior. So here, all right, so we have 1 is a critical number, so I put a tick mark there. All right, so let's find out about their sign here. All right, f prime, so we can look at, let's say, f prime of anything smaller than 1, so it's a 0. All right, if you plug in 0 into the derivative, and you can see that if you plug in 0 here, you have 1 minus 0, so it's positive, so this is positive. So the derivative at 0 is positive, right? But if you look at the derivative at, say, x equals 2, we have a 1 minus 2, so that's negative, so it's going to be negative, right? So if you look at the original function f, we know that the graph is going to be before 1, so derivative is positive, so increasing. After 1, this is going to be decreasing, which tells you that there is going to be right here, right? We know the shape, so this is the top of the hill, so you have a local maximum there, right? So let's find a corresponding value, right? So if you plug in 1 into the original function, you will have 1 times e to the negative 1. So you have a e to the negative 1, right? Or 1 over e either way, right? So let's type it in. Right, so we have a maximum, a relative minimum, so this one does not exist. Right, there's only one critical number we found. Right, then relative minimum is going to be, relative maximum is going to be at 1 comma. Right, let's see, I'm going to put that 1 over e, or e to the negative 1, either way is fine. So let's go ahead and check the answer. All right, it came back and looks like we got this one correctly here. All right, so once you know that, we can probably choose the correct picture. All right, so it's increasing before 1 and decreasing after 1. All right, so obviously number 1 doesn't follow that. Here, increasing before 1, decreasing after 1. So number 2 is very promising. Right, this is number 3, totally wrong. Number 4 is actually totally wrong too. So this is going to be the correct picture. All right, so I'm going to just go ahead and check the answer. Submit for testing. All right, it came back. Looks like we got this one correctly. All right, so let's find the inflection points and asymptotes. All right, so here. All right, inflection points, we have to look at the second derivative. So we take another derivative, f double prime of x is equal to. All right, so I'm going to look at this as the first guy, and this is as the second guy. All right, derivative of the first guy is, we already done it, right? E to the negative x, then multiply by -1. So I'm going to put the negative sign here, times the second guy, which is a quantity 1 minus x, plus first guy is e to the negative x, and multiply by derivative 1 minus x is -1. Right, so we got that. Right, again, we're gonna factor out the e to the negative x and the e to the negative x actually, and with the -1 would be good. So I'm gonna pull out negative e to the negative x, and what's left is going to be 1 minus x, and then you're going to have another plus 1, right? So this is going to be negative e to the negative x, and you have a 2 minus x, right? And if you want, we can, having a negative sign, I don't like that, so I'm going to just go ahead and distribute that. So this is going to be simply, I'm going to write negative x become positive x. Positive 2 becomes -2. Then I'm going to put e to the negative x here. Right? So we set this guy equal to 0 to find the location of a possible inflection point. So it's going to be x equals 2. Right? Right, so let's make sure that there's a concavity change at x equal 2. So here is top. So x equals 2. And we just have to look at the sign of the second derivative, right? So anything less than 2, so I'll try 0. All right, if you plug in 0 here, it's -2, so it's going to be negative. Right? And if you plug in something bigger than 2, like 3, the 3 minus 2 is positive, so that's positive. So if you look at the original function here, we know that this is going from, right, second derivative is negative, so it's a concave downward there. And the second derivative is positive, so concave upward there. So we know that there is a concavity change, so we have an inflection point there. All right, so let's find the corresponding function value. So plug in 2. So it's going to be 2 times e to the -2. So you can write it as a 2 over e squared maybe. All right, so let's type it in. All right, inflection point is going to be at 2. Right, it's going to be 2 over e squared. All right, and let's check the answer first. Submit for testing. All right, it came back and looks like we got the inflection point correctly. All right, so let's look for the horizontal asymptote. So let's say look at the picture. All right, so as you can see that this guy gets going here, you can see that this is getting closer to the x-axis, which is y equals 0. So y equals 0 is going to be the horizontal asymptote. And the vertical asymptote, as you can see, there's no blowing. This is going to eventually go to -infinity, but it's not at the finite point. So there's no vertical asymptote. So I guess we have to say does not exist. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got all these guys correctly. All right, that's it. I hope that this was clear.